Hi, my name is Jongmun Chung, and I'm a professor at Yonsei University. For the course, Deep Learning for Business, we're going to start off with looking into deep learning products and services. But first, we're going to take a look at future industry evolution and artificial intelligence, and see how artificial intelligence technology, especially deep learning, is going to influence the future of industry evolution. And then we'll take a deeper look into products and services that are influenced by deep learning technology. First of all, let's start off with the first industrial revolution, 1IR. This was from the 18th to the 19th century in Europe and America. And agriculture and rural societies experienced industrialization and urbanization. Now, driving technologies include the iron industry, steam engine, and textile industry. The second industrial revolution, 2IR, was from 1870 to 1914, right before World War I, and it was focused in America, Europe, and Japan, and other countries. Rapid growth of new industries and technologies came about. In addition, mass production becomes possible due to electrical power, oil, and steel. The driving technologies include the telephone, light bulb, phonograph, and internal combustion engine. The third industrial revolution, 3IR. It is from the 1980s until today, and it has a worldwide influence. Advancements in digital electronics and mechanical devices came about, and because of this advancement in digital electronics, it's also called the digital revolution. Driving technologies include the personal computer, the PC, the internet, and various information and communication technologies. Some of the current industry driving technologies include smartphones, wireless communication, including Wi-Fi and Bluetooth, mobile communication, as LTE and 4G mobile communications, big data, cloud computing, mobile internet, social networking services, and artificial intelligence. Then comes the fourth industrial revolution. Now, this was defined in a book from the World Economic Forum by its founder in 2016. And it's defined like this. And as you can see in this definition, it's a very good, very well-prepared definition itself. So I'm going to use this in explaining future technology evolution and its relations to artificial intelligence, especially deep learning techniques. 4IR is an evolution from the digital revolution of 3IR. In addition, future industries will have influence from deep learning and machine learning in all technical areas. Where and how will deep learning and machine learning be used in future industry? This is an example. From the data collection to big data analysis, because we have such a large amount of data. In addition, the data types are so diverse. In addition, when they're created, there's a lot of junk data. That needs to be filtered out. Considering these things, deep learning and machine learning can be very effective as a filter, as a controller to collect information and put it into the big data analysis engine. In addition, deep learning and machine learning will be used in creating real-time estimations. These real-time estimations are based upon the real-time based upon the data that is collected in real time. Then, along with real-time IoT data, Internet of Things, where the overall situational awareness, the condition, the status of the environment is included into the system, in which deep learning and machine learning is used again to make accurate predictions. Through these predictions, deep learning and machine learning can be used again to create, control, and management technologies such that we have a safe and more productive society. As you can see, deep learning and machine learning used in various different shapes and forms will be used all over the data analysis to the control all the way from the data collection. So therefore, this is a scope that we're looking at. Based upon this, it is evident to see that in future industry evolution, artificial intelligence, machine learning, and especially deep learning technologies will be assisting the development and improvement in all of these core areas that are identified as the future for the fourth industrial revolution. This includes nanotechnology, biotechnology, 3D printing, robotics, autonomous vehicles, as well as IoT, 5G, and smart devices, including cloud computing techniques. Let's get a step into further details on these technologies that you see here. First, we'll start with deep learning. Where is it categorized? Artificial intelligence is the overall bigger domain. Inside, where we have machines given the capability to learn what's going on and then adapt, is the basic domain of machine learning. Deep learning is a subset of it, which goes into further accuracy that uses neural networking technology to go in and enable more complex situational data to come in and make more precise decisions. Of course, in a later lecture in this course, I will focus more on the details of these. Then, deep learning applications include computer vision and image processing, handwriting recognition, speech recognition, data analysis and information extraction, management and control automation, predictions and estimations, in addition, program code generations, which means that you actually have deep learning applications developing program software. Quite remarkable, right? Now, in further details, let's see how deep learning technology, in what areas of these other areas can it influence? Nanotechnology. Well, this is defined as a matter manipulation technology at dimension scales of 1 to 100 nanometers in at least one dimension of the matter itself. Nanotechnology science and engineering fields include these fields. Then comes biotechnology, and there's a couple of categories about this. Bioinformatics to start with. Computational techniques applied to solving biological problems. Blue biotechnology, focused on marine and aquatic biology technology issues. Then we have red biotechnology, focused on improvements in medical processes and medicine as well as treatments. Then we have green biotechnology, which is to improve agriculture processes and productions. In addition, white biotechnology, which is focused on energy, industrial production, transformation, or dissolving of various things. Then we have another area called 3D printing. This area is also called additive manufacturing. Additive manufacturing is like the technology that enables 3D printing, because the 3D printing process is a process of additive manufacturing itself. So these terminologies work together. And if you look at the various types and production methods, it's evident where artificial intelligence and precision deep learning techniques can contribute to 3D printing and AM techniques. Then comes robotics. It's evident that deep learning technology can influence and help improve robotics. Anyway, let's go into some of the details. First, industrial robots. Automatically controlled robots for industrial applications which commonly have jointed arms and an end effector. In addition, modular robots. These are robots designed to enhance utilization and functional effectiveness in various other systems. Next are service robots, fully or semi-autonomous robots that can perform services useful to humans and equipment. We have collaborative robots, cobots. These are robots designed to interact with human workers to enhance productivity, reliability, accuracy, or safety. Another domain is educational robots. Robots to serve as educational assistants for teachers or self-learning facilities. Then we have mobile robots. These are robots that can move around an environment. They're used in factories and assembly lines, and they commonly follow a marker, a rail, or wires that are located around them. In addition, these type of techniques can be found in automatic guided vehicles, AGVs. Now, to enhance up the level of mobility, we now enter autonomous vehicles. We have unmanned aerial vehicles, such as drones. We have unmanned surface vehicles, which include autonomous cars, carts, trucks, trains, boats, and watercrafts. In addition, there are unmanned underwater vehicles, which include submersibles, robotic submarines, and others. Looking into the domain of IoT, Internet of Things, 5G, and tactile internet, of course, it's very evident where deep learning can contribute. Looking at where we are right now for smart devices and the mobile internet, we're moving into the domain of having IoT connected to clouds and more diverse big data analysis and data control used. Then we're moving into the domain of what you see right here. That's the 5G, tactile internet, and smart IoT domain. Some of the things that we can get when this comes about will be IoT hyperconnectivity, ultra-low services based on 5G mobile communications, tactile, haptic, HCI applications, as well as various smart techniques and smart products and services available, such as smart cars, smart home, smart businesses, and smart factories, to name a few. So as you can see, where will deep learning be contributing in the future is pretty evident. All of these areas that you see right here are going to be influenced by deep learning, especially in domains of precision analysis, predictions, control, and automation. So that's why we're going to focus on deep learning technologies and see how it influences business in this course. Now, in the following lecture, we're going to go into products and services that are currently available or will soon become available. These are the references that I used, and I recommend them to you. Thank you.